In this third video, we are going to graph a log function and an exponential function. In order to graph the log function, we'll first put it in exponent form. So we'll start by subtracting 3. Y minus 3 equals log x minus 2. Now that's log base 10 or common log. So a base 10, we'll cancel it. So we have 10 to the y minus 3 power equals x plus 2, x minus 2. So if I add that 2 to both sides, I'll get plus 2 equals x. So we can make a chart, x and y. Whatever the power is, and the power has a y in it, that's the variable we'll start with. So 0, 1, and 2 for y, and we'll see where that takes us. So we have 10 to the 0 minus 3, so that's negative 3 power, plus 2, and that's 2.001. Then we'll try the first, y is 1, so that's 10 to the 1 minus 3, so that's 10 to the negative 2 power, plus 2, and that is 2.01. Then we'll try a 2. So that's 10 to the 2 minus 3, which is negative 1, plus 2. That's 2.1. So let's try 3 and 4 for y. So with a 3, that's 10 to the 3 minus 3, or 10 to the 0, which is just 1, plus 2 is 3. Then we have 10 to the 4 minus 3, so that's 10 to the first power, which is 10, plus 2, and that's 12. So we've got 2.0010, so just past 2, 0. 2.011, 2.1, 2, 3, 3. And then 12, 4. So this goes up to 10, 11, 12, 1, 2, 3, 4. So about right there. So our graph takes us out this way, and then on this left side, it's just going right along x equals 2. It'll never actually touch x equals 2. It'll always actually stay just to the right of it. Next we have y equals 1/4 times 0.5 to the x power. This time the variable is x, so we'll start with x. We'll go 0, 1, and 2 and see where that takes us. So if I put in a 0 power, so that's 1/4 or 0.25 times 0.5 to the 0 power. That's 0.25. 0.25 times 0.5 to the first power, 0.125. 0.25 times 0.5 to the second power is 0.0625. So it's getting closer and closer to a y value of 0 as we go farther to the right. Let's go the other direction. Negative 1, negative 2, negative 3, and we'll see what happens there. 0.25 times 0.5 to the negative 1 is 0.5. 0.25 times 0.5 to the negative 2 is 1. 0.25 times 0.5 to the negative 3 is 2. We're still fitting on the graph, so let's go a couple more. Negative 4, negative 5, maybe negative 6. We'll see what that does. 0.25 times 0.5 to the negative 4 is 4. Negative 5th power gives us 8. The negative 6th power puts us off the graph. So we have 0, 0.25, 1, 0.125. So on this side, it's going to just be hovering just above y equals 0. Then negative 1, 0.5, negative 2, 1, negative 3, 2, negative 4, 4, negative 5, 8, and then it goes pretty well off the graph. And on the right side, it hovers just above the x-axis, never actually touches it, but gets infinitely close. This type of equation right here is an example of exponential decay. In our last video, we will do some problems involving exponential growth and decay.